Okay, internal energy, enthalpy and specific heats of solids and liquids. So for incompressible substance, okay, for solids and liquids, a substance whose specific volume or density is constant. So we assume that it's not it can't be compressible for solids and liquids. Okay, solids and liquids are incompressible substances. Okay, just now we have ideal gases, right? So this time we have solids and liquids. Okay, for liquid V is constant. V liquid is constant. So solid is constant. So the specific volumes of incompressible substances remain constant during a process. You don't need to worry about the dV anymore. Okay, there are no changes of volume, specific volume. Okay, so in this time, therefore, if the volume is constant, so you don't need to worry about what kind of specific heat that we are using anymore, because C must be equal to CV and CV is equal to CP. It doesn't matter anymore. Okay, both can be used. Okay, so for iron at 25 degrees Celsius, specific heat is actually the same with CV and the same with the CP, and we have only one value for specific heat. Okay, for solids and liquids. Okay, the CP and CV values are incompressible substances are identical and are denoted by C only. So you can just use C. Okay, internal energy changes. So this is coming from the previous equations. Du equals to CV dt. Since we can use CV is equal to C or CP, you can just use CT dt. Okay, so du equals to C dt. Delta U equals to U2 minus U1, which also equals to C dt. Okay, therefore delta U equals to C average T2 minus T1. So for enthalpy changes, H equals to U plus PV. Okay, but this one you have P and V. Okay, enthalpy changes P and V both can be changes as well. Okay, how about we derive in terms of P and V as well? dH equals to du plus V dP plus P dV. Okay, because this is differential equations, right? We differentiate PV into V. We constant the V first, and then we constant the P later. But dV is equal to 0 for solid and liquids. Okay, therefore we have this equation. dH equals to du plus V dP only. So this is the equation for solid and liquid. Okay. Therefore, delta H equals to delta U plus V delta P, which is actually it is equal to C average delta T plus V delta P. So for solids, the term V delta P is insignificant, and thus delta H is equal to delta U. Okay, equals to C average delta T. Okay, for liquids. Okay, okay, this is for solids. Okay, we just assume that delta H is equal to delta U, because V delta P is too small. The gap is too small, so we can just ignore the V delta P. So delta H equals to delta U. Okay, which delta U equals to C average delta T. Both are the same. But for liquids, two special cases are commonly encountered. For constant pressure process, as in heaters, we assume that delta P equals to 0. So delta H equals to delta U equals to C average delta T. So it's just the same. But for constant temperature process, as in pumps, delta T equals to 0. Therefore, delta H equals to V delta P. Okay, because delta T equals to 0. Okay, so the enthalpy of a compressed liquid, okay, H equals to HF at that specific temperature plus Vf at that specific temperature, okay, in bracket of P minus P set at that specific temperature. So a more accurate relation than so this is a more accurate relation than H at that pressure temperature is approximately the same with HF at that specific temperature.